In readme.txt, we show that the power consumption graph is generated in PDF using the Power Tutor app, and the extra credit collect user button is shown to predict.
Hi, we are from group 11 and this is the video which shows the source code and the demonstration of the application. Here we start off with the main activity, and I am Keethna Mohan, contributing to the parts of main activity. In the main activity, we are declaring the variables used in the application, and in the on create we are creating a database, and then we would like to define the buttons used in the application, buttons as well as the radio groups which are used, and also the graph. In the start button we are checking if any of the radio buttons are clicked. If it is clicked, then the rows are inserted into the database, and to sense the accelerometer readings we are creating a service. And then comes the DB to text button. In that we are converting the database file into a text format. And then comes the plot 3D button. In that on click listener we are creating a new activity. And then comes the accuracy button. In the accuracy button we are trying to print the accuracy of the SVM model. Then comes the power button. In the power button we are plotting the 10 iteration values that which we got from the Power Tutor application. And then we are checking for the permissions to access the file from the external storage, which in case if it is given, then the application can proceed. Otherwise there will be a toast stating that the permission is denied. This is for read as well as writing, for reading as well as writing in the external storage. Then comes the set param of method. In the set param of method we are setting the parameter of the SVM model to default values. Then comes the read problem of model. In the read problem of model we are reading the text data that was created and checking for the format.
Hi, this is Kamakshi Gupta. Next we have the function do cross validation for k-fold cross validation. In this we first check if the parameter SVM type is either epsilon SVR or new SVR. Then we have a for loop for calculating different variables, and we print the mean square error and correlation coefficient. In the else condition we display the calculated accuracy, and then we print error statement if the string is infinity. Next we have stop service function for the sensor handler. Now we will go to sensorhandler.java file. This file is also run by me. Firstly, when there is a new sensor, then the sensor event listener is used to receive notification, and at new sensor event this on sensor change is called. The bind service is used to bind the client to a service, and client uses iBinder argument to communicate with bound service. We use onCreate to initialize the activity, and then we use onStart command to start the service by client every time. Then we unregister the sensor listener in this function on destroy. And finally, when all the clients unbind the service, it is destroyed. Thank you.
Hi, this is Sangvi Jaigopi, and I have written the database file for handling the data operations from the accelerometer. So first I create a table with 50 columns for each x, y and z axis of the accelerometer, and there is a label associated with each activity. After the table is being created, I insert the rows for the columns. So with each recording of the activity, the data gets inserted into the table. Then I do update row where as new value comes in, it replaces the existing row of data for every activity and each time the activity is recorded. I use the extract data function and I associate it to a 2D matrix for each activity, and for walking the label is set to 1 and running to 2, and for jumping activity it's 3. Then there is a convert file function to take the values from database and convert it into a text file. The data for visualizing is
Hi, I'm Aditya Selvam. I've done the part of getting the data from the database and visualizing the different activities in the graph. SQLite database is created and the contents are obtained from the database. I've created a array list for walking, running and jumping actions. Also created a JSON object, and walking is labeled as activity number 1, running as 2 and jumping as activity number 3. According to the labels, each activity is appended based on its points, so that covers all the 60 readings. This is the JavaScript part of the visualization. Plot ly package is imported. 3 different colors are given for 3 different activities. The marker size, the line size and the number of points and their color are mentioned. The data is parsed from the database and each color represents a different activity. A button is also added for selecting separate activities like run, walk and jump, and viewing them separately in the graph. Zoom and rotate.
as a part of extra credit for predicting the human activity recognition. We build 2 files, svmtrain.java and svmpredict.java. This svmtrain.java takes the data that we record for the activity and sends it to the SVM model, and the SVM model output acts as an input to an intermediary model, and based on the input of the intermediary model, the activity is predicted for the human, and it is done using 2 functions called read problem and predict. The app, the first thing that we do is to click on the type of activity, and then we start recording the activity each for 5 seconds. First is walking, then running, and then jumping. So all these data is fed into the database. Then accuracy is calculated by clicking on the accuracy button. Then we convert from db to txt and it's stored in that path. Then we plot the graph, 3D graph, which shows the graph values for running, walking and jumping. By unclicking walk and jump, we can see the graph for run activity. By choosing walk, we see the graph for walk activity, and by clicking on jump, we see the graph for jump activity. And we can see the graph for all 3 activities too. Then we calculate power by clicking on the calculate power button, and it generates a graph. Then we are testing the collect user button where it predicts the activity being tracked, and for walking it works perfectly predicting, and for running it is giving the correct prediction, and for jumping, as the button is clicked, it predicts that we are
jumping.